We are attempting to look at trigonometry this time around, but looking at problems that require us to simplify, the type of questions that focus on reduction formulae, and the notion of reduction formulae is at the center of trigonometry at school level, and we focus on this. If you need to simplify sine squared of theta divided by the sine of 180 degrees minus theta times the cosine of 90 degrees plus theta plus the tangent of 45 degrees. We look at the solution to this in a step-by-step fashion as follows. Okay, if you have this particular question, what do we do? The numerator is already a single trig ratio, so we leave it as it is, as sine squared of theta. The numerator is okay. And then the denominator, you need to think of where this is, okay? 180 minus theta, in which quadrant is 180 minus theta? Do you remember that? We forgot because we discussed this a little bit. Okay, quadrants. Right, 180 minus theta. 180 minus theta is in the second quadrant. And in this,
right?
Yes, in the second quadrant, I drew the cast diagram yesterday, but I'm going to look at it again today. So it's in the second quadrant. The second quadrant is a quadrant in which the trigonometric sign itself is positive. So you're going to have the sine of theta. 90 plus theta is in the second quadrant. The cosine is negative in the second quadrant. So negative. But there's a co-function change because at 90 degrees, you remove the co and you're left with sine theta. Okay, the tan of 45, the tangent of 45, 45 is a special angle, and the tangent of 45 is actually equal to 1. Like so. In the numerator, then we have exactly sine squared theta, 1 minus sine times sine is sine squared of theta. The numerator therefore remains as sine squared of theta divided by, what is 1 minus sine squared? 1 minus sine squared is actually cosine squared. Sine over cosine is a quotient identity, and sine over cosine is the tangent squared of theta. So yeah, we're done with this. The tangent squared is a single trigonometric ratio of theta, so there's nothing for us to do to sort of simplify these. Any question, please?
No.
No question. So you get to think of this. Now, a couple of things I want us to sort of make mention of. The cast diagram is a very important one. Okay, so if you have 0 degrees here, you have 90 degrees there, you have 180 degrees there, 170 degrees there, and 360 degrees there. So all positive. Cosine theta, tan theta. This is the trigonometric sign of what? Of theta. Okay, this is sort of the cast diagram. And now if you have, for example, so if you're here and you go back like this, is you have 180 degrees minus. And that puts you, this is quadrant 1, this is quadrant 2, this is 3, and this is 4. In which case, therefore, if you have this one plus 180 plus theta, this is minus theta, this is plus theta. So 180 minus theta is in quadrant 2, in which the sign is positive. That is why this is positive. 90 plus, okay? So obviously, if you're moving from 90 to 180 degrees here, you'd actually therefore be talking about 90 degrees plus theta. Okay, 90 degrees plus theta. 90 degrees plus theta puts you in the second quadrant, in which only the sine is positive, and therefore the cosine becomes negative. But there's something I spoke about, and I'm going to reiterate that, called the Coco rule. Right, so the Coco rule actually indicates one thing. So the Coco rule means that we have that if there's a co at 90 degrees, you remove the co, so there's cosine, and you remove the co and you're left with sine. If there's no co, then the co rule says you put on the co getting a cosine. Okay, so right. So just focus on that and get to think of these things. Next question. Now here, the next question is as follows. Right. So in the next question, we have the sine of 104 degrees, and then we have 2 into cosine squared of 15 degrees minus 1. The tangent of 38. So in here you have the sine squared of 412 degrees. So a couple of things we need to think about here. Okay, there's a giveaway here for the identities that we need to remember. We need to remember that when we have cosine 2x, it is 2 cosine squared x minus 1. So yeah, cosine 2, this. So right now, what we have, right, is now you have 104 degrees, and now you have 38 degrees here. So you need to think of the right sort of reduction formula, because now here you have 412 degrees. So you need to think of how you can deal with these in a very, very useful manner. Let's reason together. The 104 degrees can be seen in many, many ways. How can it be seen this one? So you can write the sign here. Right. A couple of ways to do this. If you think, for example, that in the denominator, you have the tangent of 38 degrees, and 38 is a reasonably small angle, so you can, in the meantime, keep 38 degrees. Okay, we're tending to reduce the larger angle, so at this point here, you have the sine squared of 412, which is 360 degrees plus, okay, so which is actually 52 degrees. Okay, let's check this one. Because if you have 360 plus 52, you're getting exactly 412.
Yes.
412. Okay, good. So you think you need to make sure that these numbers are correct so that it works beautifully. So in other words, if you have 360 plus 52, you get exactly a 412. And then now you have this one, which is 104 degrees. This 104 degrees can be related to this. How is it? Obviously, because it is an obtuse angle. So you need to reduce that. So you can look at it as 90 degrees. 90 degrees plus 14. 90 degrees plus 14 degrees. So cosine 2x is 2 cosine squared minus 1, which is cosine 2 into 15 degrees. 2 into 15 degrees.
What happens to the 1?
Okay, because cosine 2x is equal to 2 cosine squared x minus 1. It's an identity. It's sort of the formula we're using. So because cosine 2x has 3 identities, and we're going to discuss this again in detail, cosine 2x can also be written as cosine squared x minus sine squared x. Okay, but also cosine 2x can be seen as 1 minus 2 sine squared x. Okay, so that kind of thing that you have there. Okay, now let's continue with the analysis of this. So the top, for example, in which quadrant is 90 plus? It's in the second quadrant in which the sign is positive, but at 90 degrees is a cofunction change. So this is going to become cosine of 14 degrees. Cosine of 30 degrees. Tangent of 38 degrees. 360 plus is in which quadrant? 360 plus is in the first quadrant where all the functions are positive, and therefore this is what can be seen as the result is positive, but it becomes therefore just a sine squared of 52 degrees. Okay, now let's look at these and think carefully and see. 30 degrees is a special angle, so we're good. And therefore, we can fix that out. 14 degrees is actually a very interesting smaller angle. So 52 degrees now can be made similar to any of this. For example, somebody can look at the 52 degrees and you can minus something from it. What can you subtract? You can subtract 38 from it. Okay, so now what do we have here? So in the numerator, we have cosine 14, cosine 30. Right, so we have cosine 14 degrees. We have cosine 30 degrees. Okay, so, which is tan 38 degrees. The sine squared of 52 degrees. Okay, so we have this. Now, in the denominator, we can keep the 38 degrees. And then we reduce this one to 90 degrees minus 38 degrees. 90 minus 38 is 52. Cosine 14 degrees. Cosine 30 can be quickly done. Right, because if this is 60 degrees 30, so which means cosine 30 now in view of SOHCAHTOA. The cosine is adjacent of hypotenuse at 30. Adjacent of hypotenuse at 30, so which is the square root of 3 out of 2. So which means therefore we have the tan of 38 degrees. 90 minus is in the first quadrant, 90 minus theta, 90 minus 38 is in the first quadrant, in which all the functions are positive, but that is all the trigonometric functions are positive, meaning the sign is positive, but there's a co-function change at 90. So that sign, according to the Coco rule. Right, so we use the Coco rule, and the Coco rule is clear on this front. And the Coco rule says that if there's no co, you put on the co, and sine becomes cosine, and only write cos squared of 38 degrees, like so. So let's see what we get here. So now at this point, what do we get here? In the numerator, we still have the cosine of 14 degrees divided by the denominator, which is the tangent of 38 multiplied by cosine squared of 38. 38 degrees, and here we have the square root of 3 out of 2. Okay, now let's look at what we get here. Okay, now at this point in the denominator, what you have is the tangent is the sine of 38 using the quotient identity over cosine 38 degrees. And this is cosine squared 38 degrees. Okay, this one here, you can write here the cosine, you can write the square root of 3 and then put the 2 here. And then here you have cosine 14 degrees. Now, at this point, you perform cancellation here. Cosine 38 is going to cancel one of these, leaving us with a 1. So now that means that we have the following. Square root of 3 cosine 14 degrees divided by 2 into the sine of 38 degrees times cosine 38 degrees. Super question. Now, this is very important for us because we have this. Now, the cosine 38 has just removed one of the, because here there was cosine squared, so there was cancellation. There was cancellation here. Okay, right. So this is equal to square root of 3 cosine 14 degrees divided by 2 into the sine of 38 degrees cosine 38 degrees. We need to recall some identity here. These were super questions during the years of higher grade mathematics. So that sine 2 theta is 2 sine theta cosine theta. I have a strong feeling this one came from the past higher grade papers to the book I'm using. Right, and therefore this is cosine theta. So wherever you see sine 2 theta in mathematics, it is 2 sine theta cosine theta. It's an identity. It is an identity. So that in the end, we can get what? The square root of 3 which is divided by, now 2 sine 38 cosine 38, like 2 sine theta cosine theta is sine 2 theta, so its sine of double the angle is called a double angle formula. So it's 2 into 38, sine 2 into 38 degrees. (14 degrees divided by). Okay, now what is 38 times 2? Looks like it's 76 degrees.
Yes.
Okay, good. Right, etc. This appears to have come from some of the higher grade papers in the past. It looks quite an aggressive question, a bit lengthy as well. So now, the authors of the book, sometimes they use old questions that were very, very aggressive. So cosine 14 degrees, you divide by the denominator, which is exactly the sine of 76 degrees. Okay, you need to simplify this. The way to simplify this is to make 14 like 76, or to make 76 a 14, but in a mathematically correct way. So you need to think of some of the reduction formulae. You can say 90 minus something. Okay, the practice is to reduce a larger angle to a much smaller angle. Okay, these are both acute angles. Acute angles are those smaller than 90 degrees. So, which means we can take this 76 and say, if we are to say 90 degrees minus 14 degrees, that must be about 76. Okay,
Right, 76.
76, good. So yeah, so these questions, what you need to do with these questions, you need to repeat them. Repeat them. Okay, you repeat these questions to make sure that you're good. All right. Okay, we'll continue. So square root of 3, 14 degrees. Okay, now there's a cofunction change here. Okay, watch the cofunction change that you're getting. Because at 90 degrees, according to the, we use the Coco rule, and the Coco rule dictates a little bit of cofunction changes. So now we have a 90 in the denominator. So we're going to use the Coco rule. And the Coco rule says now, if you have 90 degrees minus, 90 minus is in the first quadrant where all trigonometric functions are positive. So the answer is going to be positive, but it's going to change from sine, because sine is no co. You put a co, it becomes cosine. And the minute you write cosine, we write only cos of 14 degrees. And we are in business now because you can see this one cancels this.
That's
And the answer is the square root of 3. Okay, so quite a lengthy question, but I'm sure that you've had a chance to sort of explore a little bit and learn a thing or two from it. And there are a lot more questions that we're going to be doing this morning just to make sure that we good enough to learn and master mathematics and make sure that you scoop the distinction. We have a lot of work to do. Please, it's not just uh jokes and whatever. We have a lot to practice. We have a lot of mathematics to do. We have different questions to practice. How do you learn mathematics? You learn with repetition. So you repeat and repeat and repeat and repeat until you're good. Until you're good. Let us look at this particular question here. More reduction formulae. Okay, this one. Okay, we're trying to simplify here. So the instruction in the question is clear. It says simplify. Right. Simplify when you have been given the sine of 90 degrees minus theta, the tangent of 180 degrees minus theta, divided by the cosine of minus theta, the sine of 180 degrees plus theta. So we need to remember what we have learned in terms of the cast diagram. So here you have cosine theta, all positive, the sine of theta, the tangent of theta, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So now here you would have 180 degrees minus 180 plus. 90 degrees minus to go back. Okay, pretty enough for this question. But a couple of things are very important for us to remember. This is the first one, the first quadrant, the second quadrant, the third quadrant, the fourth one. Okay, let's look at these now. 90 minus theta, in each quadrant is 90 minus theta, according to the diagram.
the second one.
Please check again. 90
Oh,
minus
the first.
the first. Okay, the first. But all positive here. So sine is positive here. So sine is positive, but there is a co-function change at 90 degrees. So there's no co on the sine, put on a co, and it becomes cosine theta. 180 minus theta in which quadrant is it? It's in the second. And the second quadrant on the sine is positive, and therefore the term is negative there. So now cosine of minus theta, the cosine is an even function. So cosine of minus theta is just cosine theta, like this. 180 plus theta is in the third quadrant, and the third quadrant only 10 is positive, and therefore the sign is negative. Okay, what do we get out of this here? Cosine cancels out, negative cancels out, and we're left with negative. Yeah, negative cancels out, giving us a positive, and therefore we have sine theta. Yes. The tangent of theta is sine over what? Cosine theta. Okay. Tan theta is sine theta over cosine theta, which is sine theta over 1. And then here you have sine theta over cosine theta multiplied by 1 over sine theta. Okay, so look at this. Okay, so now obviously if you're dividing by sine theta over 1, is the same as multiplying by 1 over. Okay, so it's the law of division. So in the end, then what we're getting here is that you have 1 over cosine left, so which means the answer is actually equal to 1 over cosine theta. So here's the question. We had to simplify this and went through this and we got 1 over cosine, and the answer is 1 over cosine theta. Another question? Still, we need to proceed to simplify. Right, so we need to simplify the following. If we have the sine of 180 degrees minus x, the cosine of 90 degrees minus x, divided by the cosine of 360 degrees minus x. 90 degrees plus x. So you have cast here. All positive cosine theta, sine theta, tan theta. We have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So if you have like 180 degrees minus theta, where in this quadrant, this is quadrant 1, 2, 3, 4. 180 minus is in that one. Simultaneously, if you have 90 plus, it's here. Here you have 90 degrees minus theta. Okay, now we continue. So this one here is going to be 90 degrees minus. So 90 minus is in the first quadrant. 90 plus is in the second quadrant. 360 degrees minus theta. So 180 minus is in the second quadrant where the sign is positive, so this one is going to be positive. 180 90 minus. 90 minus is in the first where all the functions are positive there. But there's a co-function change at 90 because there's a co, according to the COCO rule, remove the co from cosine and you get the sine of x. In the denominator, you have the 360 minus x. 360 minus theta is in the fourth quadrant where only the cosine is positive, and therefore the result is going to be positive cosine x. 90 plus is in the second quadrant. In the second quadrant, we know very well that only the sine is positive, and therefore the cosine becomes what? Becomes negative. But it's a co-function change because you have 90. If there's a the Coco rule,
It's going to be sine.
it's going to be sine. Under the Coco rule, if there's no if there's a like you have cosine and you cross out the and you are left with only the sine. So in other words, here, because it's 90 degrees, you must remove the and remove the left with the sine. But 90 plus is in the second quadrant where cosine is negative sine. Okay, let's check what we're getting here. Right, any cancellations of things? Like we can see sine and sine.
Okay.
Right, so you can see sine and sine appearing. So sine cancels out. You can cancel even either this one and that one. Okay, so just canceling two of them. One sine in the numerator and another one in the denominator, and therefore you have minus, and you have minus sine x over cosine x, which is minus the tangent of what? Tangent of x, and that is the answer to this.
Where we get the tangent?
Because sine over cosine is always tangent. Okay, it's called the quotient identity. Quotient identity. So we learn that the quotient identity is that if you have the tan of x, it is sine x over cosine x. It's called the quotient identity. It's a quotient. Next question. I want us to just look at a lot of these simplified questions so that we can sort of have a pattern here of mastery. (180° plus x). Divide by the sine of minus x times the cosine of 360° minus x. Okay, I need to recall the diagrams that we drew. So you have this one called the cast diagram. So if this one is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So now, okay, let's look at these. So at this point, if you have, this is the usual cast diagram, cast diagram. So here you have 180 degrees minus, and then here you have 180 degrees plus. Right, you have this. And here you have 360 degrees minus theta. Okay, now look, there are a couple of things I want us to sort of focus on here that remain extremely important for us. Okay. Okay, 180 minus is in the second quadrant. So 1, 2, 3, 4. So now at this point we have 180 minus. So now if you have 180 minus, you are in the second quadrant in which the sign is positive, so it's going to be positive there. So this is going to be positive and is positive sine x. 180 minus x is in the second quadrant where the sign is the only one positive, but the cosine is going to become what? Negative. Cosine x. Now you have the tan of 180 plus x. 180 plus x is in the third quadrant, and the tan is positive there.
Positive.
Yeah. Yeah. So it's the tangent of x. Because it's 180 plus, and 180 plus puts us in the third quadrant, and the third quadrant. Yeah, the tangent is indeed positive there. Next. The sign of minus x is minus sine x. 360 minus, in which quadrant is it? It's in the fourth.
The fourth.
And the fourth, only the cosine is positive, and therefore we have cosine here, and therefore it's going to be positive cosine x. So now in the end, what we have is therefore that you do cancellation of the things that are popular and the common ones. Yes. And so what is the answer? What are we left with here after cancellation? What do we have? We have the tangent of x. Okay, because the rest of these things are gone. It's only tangent that's left, but you have the negative and negative. And negative and negative, they give us a plus, giving us the tangent of x. So this is sort of one way to simplify this problem. The next thing I give is a home activity for you. Right, home activity.
Sunshine, you said we're going to do those corrections. We didn't do them.
Yeah, okay. We're gonna we're gonna do them. But it's very important you can just remind me in terms of which particular ones, because I'm sure there are a lot. Okay, there are a lot of things, you know. So I need to just be sure so that I can do the ones that
I sent you the last time, and I said can we discuss them.
All right, that's fine. I'm going to take a look at those and we shall do them. Okay. Right. So you have 360 degrees plus theta. -360 minus theta. So you divide here. You divide by the sine of 180 degrees plus theta plus the sine of 90 degrees plus theta divided by the cosine. Okay, this is the home activity that you need to try. So given this, try this and see what you get. And then we shall meet again. I'm projecting 8 p.m. as our lesson time, but we can do a lesson before that. Okay.
Or we can do a lesson before that.
Before 8 p.m. Yeah, but I'm going to check on you and see your program for the day.
Yeah.
Yeah.
What time?
I'll have to check.
We can't discuss those ones you took.
Yeah, the corrections, right? We can discuss the corrections, right?
Sunshine, I can't hear you.
Yeah, we can discuss the corrections.
Yeah, that's for some.
Yes.
Yeah, the corrections.
Yeah, we shall discuss the corrections.